Okay, you guys want to take a look at similar triangles, angles, and sides. So similarity, what does that mean? Similarity tends to talk about objects that are similar in shape, but not necessarily in size. So in this case, we have the same shape, not necessarily the same size. And the symbol we see for that, so we've looked at the symbol congruent. This symbol here talks about the similarity in the shape. So we would say this triangle is similar to this triangle. Now, in order for something to have the same shape, it should have the same angle measures. So let's say this is ABC, and we're saying that this triangle here is DEF. Okay? And let's say we come up with a similarity statement. Triangle ABC is similar to DEF. And we'll use that as we go along. Now, if I have angles 20 and 80 here, and let's say I want to find out what is the angle for F, one thing I can identify is, well, I know A and D, angle A and angle D are corresponding angles. So if angle A is 20, I could say angle D here is also 20. I probably should have put, and you know what, let's do that. I probably should have put D here. Let me put D here, and I'll put F here. Okay? And then let's make this X. So let's say, okay, angle A and D are similar. They're corresponding parts, so angle D is going to be 20 degrees. Because if they're the first letter in each congruent statement, that means they're similar. Same thing with angle E. Here is 80 degrees because B and E are the second letter in the... Now, I know a triangle has 180 degrees. I know I have 100 degrees so far. So that means this last angle here is 80 degrees. So I could say 80, 80, here also 80. And if angle C is 80, angle F will also be 80 degrees. And what you see is, anytime you have triangles that are similar, even like we've been working with the 30, 60, 90, if this triangle is to be similar in shape, it has to have the same angle measures. Now, that's different. It changes when we start talking about size. So let's look at that ABC triangle. Let's look at that ABC triangle. These are similar. This one's a little bit bigger than this. They're similar in shape. But similarity means same in shape, different in size. Although, so the shape is the same, size is different. Although, because of the same shape, their size will actually create a proportion. I think I spelled this right. Meaning, if I had two sides of one triangle and maybe a third from another, let's try to keep this even numbers. So we'll say, and I'm trying to find what is the value of this side here, and I have a congruent statement. ABC is similar to DEF. One thing I could say is, okay, I have AB. AB is similar to DE. So if I'm setting up my proportion, I'll put AB and DE on the top. Because basically what we're saying is the ratio of AB to AC will be the same as the ratio of DE to DF. Now if you see my AC, my first and last, match up with my first and last of the other triangle here in my congruent statement. Now I can set this up. Let's put the purple here so we see that these colors are showing that these are corresponding parts, meaning they're in the same location of a different triangle. Now what do I have? I have 6 or 8 over 10 is the same as 16 over x. And if I'm trying to solve a ratio, all I'm going to do is just cross multiply. 16 times 10 is 160. Divide by 8. And x is equal to 20. And that's how I solve for the side here. So basically, anytime you're working with sides in your similar triangles, you're just trying to find, okay, the ratio of AB to AC is 8 to 10. I want to match it up with the other triangle with matching parts. I matched up the DE with the AB, and I matched up the DF with my AC. And then once I'm able to set up this proportion, substitute in the values, I could cross multiply. And it makes sense. I mean, think about it. You know, 8 to 10, if I set it up 8 over 10 is equal to 16 over 20. If I reduce both these fractions, it would be 4 over 5 and 4 over 5. So the ratio is the same, like if I were to reduce these. Remember, angles would be the same. So if this angle A was 50, this angle D was 50, but the sides will be a proportion.